Hello everyone, welcome to this session. Our chapter is waves, and we're still discussing about these various behaviors of the waves. So far in our previous video, we discussed the two of them, the refraction of waves and the reflection of waves. So today, let's move on to the other behavior of waves, that is the interference. We'll start with the concept of interference. What is the meaning of interference? Interference, this is the phenomenon in which two waves they superpose to form a resultant wave of greater or lower amplitude. We discussed these various terminologies related to waves such as this amplitude. So when we're talking about the interference, this is the phenomenon in which these two waves they superpose to each other just to form a resultant wave. Resultant wave is that wave that is obtained after these two waves they superpose to one another. So this resultant wave resulted is of greater or lower amplitude. So that's the interference. That's the meaning of the interference. When you're talking about the interference usually it refers to the interaction of the waves that are correlated or they correlate with each other, either because they come from the same source or because they have the same or nearly the same frequency. So when we're discussing about the interference, we're usually discussing about the interaction of these waves that are correlated to one another or they are correlate. It means they are related to one another in some way, either because the reason of their correlation or they are coherent is because they come from the same source, or just because they have the same or just nearly or close this frequency. So that's interference, how it occurs between the waves. Uh, let's see the types of the interference. Interference effects they can be observed with the all types of waves. For example, light waves, radio waves, acoustic waves, surface water waves, or matter waves. So this interference it can be observed, or those kinds of effects that are resulted by the interference they can be observed in all kinds of waves. Now from there, let's see the types of the interference. There's first one that is constructive interference. The constructive interference, this is the type of the interference that it occurs at any location along the medium where the two interfering waves they have displacement in the same direction. So this constructive, from the word constructive, it means that it is building something else. So it's the kind of the interference whereby it is occurring at a given location along the medium, whereby the two interfering waves they have some kind of a displacement in the same direction. So that's the constructive interference its meaning. In this case of this constructive interference, both waves they have an upward displacement, that is the upward displacement is kind of a displacement shown moving upward. Consequently, the medium has an upward displacement that is greater than the displacement of the two interfering pulses. So in this case of the constructive interference, there are these both waves that are interfered, or these are two waves that are interacting to one another. They have an upward displacement. That kind of upward displacement is leads to the leads to the greater than the displacement of the two interfering pulses that are within the interference. Hope that's clear. Consecutive interference is observed at any location where the two interfering waves are displaced upward, so it can be observed in such way. But it is also observed when both interfering waves are displaced downward. So it is not only observed during the upward displacement, but also can be also observed in the downward displacement. We'll see the diagram that is showing this consecutive interference. This is shown in the diagram below, the two downward displacement pulses. Here is the diagram. As you can see, before interference, there are these two waves. Now, after interference, this during the interference creates another this downward displacement. So that's what this interference happens. As we said, that it may happen due to these waves. Maybe they have the same frequency, so leading to such kind of interference. So that's the constructive interference. Moving on. In this case, a sine path with a maximum displacement of -1 unit, that is negative, meaning a downward displacement, interferes with the sine paths with the maximum displacement of -1 unit. These two passes are drawn in red and blue, as we've seen in the diagram. Now, the resulting shape of the medium is the sine paths with the maximum displacement of -2 units. So that's what is the resultant of these two interfered waves. So resultant shape of the medium is just the same path with the maximum displacement of -2 units compared to the first units of of these interfering waves, or these waves which they came into contact. Let's move on to the second one, that is the destructive interference. Destructive interference is the type of interference that occurs at any location along the medium whereby the two interfering waves have a displacement in the opposite direction. So there is a kind of opposite direction observed after these two waves they have been displaced to one another. So that's the destructive interference. For instance, when a samples with the maximum displacement of +1 unit meets a sine pulse with the maximum displacement of -1 unit, destructive interference it occurs. So, for instance, as we've seen here, there is a samples with the maximum displacement of +1 unit, and the one of -unit. So, resultant will be a destructive interference. So that's all I have for this session. Of the clear. Everyone discussed about the interference. Briefly, we've seen it, its concept, and the two types of the interference: constructive and the destructive. We've seen how they can happen, and I hope that's clear for this session. And thank you.